What we're going to talk about today is we're going to talk about passwords, setting up passwords in your environment because passwords are incredibly important today. Um, Passwords are like democracies. They are the very worst except everything else that's been tried. We're not going to talk about it today, but even systems such as um, biometric authentication systems, I think are actually worse than passwords. And the reason is very simple. I used to be in the Canadian Forces. Since I got out of the forces, I've been bonded a couple of times for various jobs that I've had. All of those times I've had to give my fingerprints. Recently, I got a Nexus card, which means not only did I give my fingerprints, but I gave a retinal scan to the US government so I could get a Nexus card, which means this biometrical information is all over the place and in theory can be compromised. And that's just half the problem. The other problem with biometrics is I can't change that biometrical information. I cannot change the information in a retinal scan. I cannot change my fingerprints. So once that data is compromised, that's it. That biometric authentication is no longer going to be valid. So that really does leave us with passwords. And there's a couple of variations on passwords. We're going to talk about that today. As I said, they've been around for a long time, been used to identify friend from foe, um, get you past a guard, unlock doors, those kinds of things. They are ubiquitous in our lives, so much so that we typically don't think about some of the nuances associated with them. One of the biggest issues with passwords is everybody, and I'm including myself in this everybody, it is such a day to day activity that people are lazy when it comes to passwords. We're all doing it, we're all guilty of this crime. We try and make our password authentication process as easy as possible. All of us should have very complicated and unique passwords all the time, and if you are actually doing that, you're the exception that proves the rule. People try and make their lives easier. They use tricks such we see on this slide, names and things that they can quickly associate with. All of those, with a little bit of research, a lot of these, I shouldn't speak in absolutes, a lot of these with a little bit of research can be realized and exploited in other places. Why? Because people select poor passwords. People choose very bad passwords and do very little to protect them. And it's such a huge problem because people reuse their passwords all over the place. And we just saw this with the federal government's portal site being compromised. It wasn't a compromise on the part of the feds. The federal government didn't um, create an environment where people's passwords were compromised. A site, and I can't remember the site off the top of my head, I apologize. Some site down in the state got a list of username passwords, and knowing that people reuse passwords and knowing that they were associated with email addresses, they were able to take that information and use it other places, including the federal government of Canada's Revenue Canada site. Okay? But this is especially important to us. And I'm going to ask you now so you can engage in the conversation. Why are they going to target specifically your username password combos? Anybody? Yep, you're right. Kiki, yep. Actually, Kiki, in this case, first of all, you're correct. Everything you said is correct, but there is an exception to that rule, specifically as it relates to everybody on this conversation. Why might your passwords become desirable in the future? Exactly. Yeah, exactly. Yeah, and that's exactly the point I was. And the Twitter example is a great example. I hadn't considered that. Thank you for that. But exactly, you are going to be the keepers of the keys at some point in the future. Compromising your account is an even more desirable target. So everybody needs to have discipline around passwords. Those of you who become administrators of systems, you have to be more diligent, because if your password gets compromised into that system, you've given access to a wide array of information. Exactly. Thank you. So, what are we going to do with that? First, here's your hacker. He's a cracker, and he's trying to steal your credentials for a number of various reasons. How do they do it? Well, there's a number of tactics, and one of the reasons we're setting up Debian this week is so we can actually take a look at some of these tools in our next class. In our next 2-hour class, we're actually going to take a look at the process of running something like John the Ripper to crack passwords. If you want to preview, the documents are all in this shell in Learn, in this module in Learn. There's a number of tactics that they use. More often than not, it's augmented with some kind of social engineering, and in this case, gathering information or doxing you. If they know your home address, if they know your pets' names, your kids' names, they can create dictionaries, which is one of the things we're going to look at. They can create dictionaries and target you using that. So much so that you're starting to see in some of the sites that have better password policies, they're not going to let you use a password that has the site information in it. Because, of course, they're not, because that's going to be part of a dictionary attack. Brute forcing is simply just iterating through characters, trying one after another. Rainbow tables is a little bit of an interesting thing. What they do is they decide that they're going to take whatever algorithms being used to create the password hashes. And if you recall from our last conversation, a hash is a one-way encryption of a string. All right? You can encrypt a string. If you can decrypt it at the other end, that's fine. That's great for communications and storage, but that's not very good for passwords. With passwords, what you want to do is you want to create a one-way encryption that cannot be unencrypted. We'll see when we set up a login script. I think we're going to do that next week, how that actually works. But one of the ways around trying to figure that out, rather than going through and taking each string and encrypting it, string and encrypting it, string and encrypting it, what they do is they actually create basically a dictionary of password hashes and compare those hashes. They're great for rapid analysis of password strings, but there's a couple of problems. One of the reasons why I don't think it was Windows 7, it was certainly Windows XP. I can't remember where the cutoff was. It was, I think, Windows XP, where Microsoft used the exact same encryption algorithm for every single password all the time. So, what hackers would do is they would create rainbow tables based on that algorithm, and then you had this huge gigabyte file full of password hashes, and then you could just run the hashes that hackers would pull from the Security Access Management System, or the SAM. They would compare these hashes, and then they would know what that password string originally was. They're great, but their one weakness is that if you're going to try and crack a system, you have to create a rainbow table based on that single algorithm. And the rainbow table's greatest weakness is salting and peppering, I guess, but salting the password hashes, and we'll see that when we look at creating a login script next week. Keyloggers are simple software or hardware that capture all keystrokes, and packet sniffers, which are becoming less and less relevant because most communications these days have at least one layer of encryption on them. Any questions? Alrighty. As much as possible, character diversity should be added to your passwords. However, there's new schools of thought happening along this. If you're going to have less characters, like 8 characters, then character diversity is very important. However, as we'll see in a couple of slides, it's created problems for password management, in that it's created a system that's easy for computers to figure out, but hard for us to remember. So character diversity really does apply when you've got fewer characters. The average person has 17 passwords. I think I got the stat from 2 or 3 years ago. I don't think it's changed much, but the average IT person has around 50 that they need to manage, which is just insane. So you should use some tools that help you with that. People are bad, as I said. In the Learn module, you will see a couple of dictionaries, and I have to apologize right now to everybody. I do not sanitize content for this course. The password dictionaries that we are going to use has profanity in it and has some truly ugly words in it. I do not sanitize this content. This is what you're going to see in industry if you have to use these tools. I am sorry that these are the tools that we have to use, that these are the dictionaries that we have to use, but these are the real tools, and I'm not going to sanitize them going forward. If you really have a problem, we can talk about it offline, but I'm kind of stuck with the tools and the dictionaries that the industry uses, because those are the things that you're going to need to use in your careers going forward. Okay? In those dictionaries, 1 out of every 9 people have used at least one password shown in the list of the 500 worst, and 1 out of 50 have used one of the top 20. Okay, those stats are probably going to wane over time as new users come in and are forced to use better passwords. Nevertheless, people are lazy and they tend to think that they're clever, that they're oh so clever. No one would ever think of using NCC 1701. I'm the biggest Star Trek fan in the world. No one's that clever. Everybody's clever, all right? THX 1138 was George Lucas's first movie. You know, QAZ WSX. Nobody would think of just using the 6 most left keys on the keyboard. Of course they will. 6 sixes, 7 sevens, OU812, a Tommy Two-Tone song, 8675309, or my favorite song that has a phone number in it is 6060842 by the B-52s. If you're clever and you think you figured something out, others have figured it out as well. I can tell you this story now because I don't do this anymore at all. But when I first got into IT and I started using passwords, I'm a big U2 fan. So all of my passwords would be based on U2 songs or albums. For example, the album October. Uppercase U, number 2, and then October, right? Right away you've got uppercase, lowercase, and numbers in your password. It's a great password. No one's ever going to think of it, right? U2, I Threw a Brick Through a Window, a great song. ITABTAW. It's not even a word. It's a perfect password. Of course, I don't do that anymore because it is something you can figure out if you know something about the person. So, right away we have an example of social engineering. Well done. Thank you, Kiki. All right. So good passwords have both upper and lower case, have digit and or punctuation, is easy to remember so it doesn't have to be written down, and is something that's important, can be typed in quickly so someone can't shoulder surf or look over your shoulder while you're typing. It's very important that you keep this in mind because you never know who's standing over your shoulder. You never know what their motives are. All right? Password length is a tricky issue, as is character diversity. These are 2 very tricky issues because the last thing you want to do is have a password policy that forces your users to type their passwords on post-its, stick them to their monitor, and call it done. That's the last thing you ever want to see. If you make your password minimum length too long, you're going to create problems. If you make it too short, you're going to make it easy to crack. What's the balance? I honestly don't know. The easy business-like answer is you have to balance the password requirements based on the sensitivity of the information you're trying to protect. A case could be made that all information is equally important with regards to its sensitivity. Nevertheless, if you're going to have strong password length and character diversity requirements, you have to explain to your users why. It's more important to say the why of the policy rather than this is the policy, just do it, go away, I have other problems to deal with. Some consider 8 characters a good minimum, others think 12 should be the minimum, still others think 16. You have to take a look at your environment. NIST makes a recommendation saying that 8 characters is probably enough, providing you do the other things that they talk about. but no more than making 64. All right. NIST is the National Institute of Science and Technology. They're the standards organization that sets the standards for technology down in the United States, and they have a lot of really good documents with regards to all kinds of IT policies. Wait one. Yeah, and I've actually included the latest NIST specification in the password resources in the Learn shell. So if you're having a hard time sleeping one night, it's a really dry, painfully difficult document to read. By all means, fill your boots. When it comes to passwords, try and make them as long as possible, make as many different characters as possible, and change your password on a regular basis. There are some of us who never change our passwords on websites unless we're forced to do so. So if you have a website, and again, this whole course is focused on web security, maybe you have a policy that forces your users to change their passwords, again, depending on the sensitivity of the data. Do not use personal information. Do not use ones that are found in standard dictionaries, which means you must keep an eye on standard dictionaries out there, which can take you to some of the darker areas of the web. Nevertheless, this is your career. Never use a password as the same as your account information or website, and do not use passwords that someone's shoulder surfing can easily figure out, as we've talked about. Any questions on any of that? Okay. Aging your passwords, this is another challenging aspect. If you force your users to change your passwords on a regular basis, you're going to create problems because they're not going to be able to keep reminding themselves. They have work to do. They're going to feel that they shouldn't allow the tool to get in the way of doing their job. And part of that is the password policies. Part of that tool set is going to be these kinds of policies. The last thing you want is Post-its on a monitor, and I think I have something in the news for this site about that. Some of the things you can use is obscurity, some of the things is secret questions. One of the documents I have there is there's a whole book in the library if we ever get back to the campus. There's a whole book on passwords in the library. It's old, but it's got a lot of really interesting ideas in it. Earlier on, I was talking about NIST and how it says it should have at least 8 characters. At one time, the person who's responsible, here's some suggestions for building smart passwords, but this is my favorite one so far. If you are reading XKCD, great, that's awesome. If you haven't started reading XKCD, you really should. It will make you smarter, and it'll give you an idea of certain things that might be important that you're not aware of. xkcd.com, they're an excellent site, and instructors like me use it all the time because Randall, he makes his images available for people to use. You know, just if you want to use it, that's fine. That's his mindset. And I love that. Back in the day, the earlier specifications with regards to password complexity from NIST favored the first panel in this comic, where it was a combination of upper and lowercase and numbers and special characters, but short passwords. It doesn't matter the character diversity. Computers are so good these days that, and I'm not going to check his math, but entropy is a rate of decay, or the rate of the ability to figure it out. So if you've got these 28 characters, sorry, not these 28 characters, 4, 5, 6, 7, 8, 9, 10, 11 or 12 characters or whatever it is, at some point, given a strong enough computer, they will figure it out. However, if you have something like correct horse battery staple, please do not use correct horse battery staple as a password on any sites. But if you have that, it's quite a bit more difficult to guess, even if they're all lowercase. And the person who developed the specifications from NIST acknowledged that. They said, you know what? He's right. Longer is better than short and with character diversity. Okay? Govern yourselves accordingly. The problem that Randall doesn't address in this is that if you allow people to use words, you can dox them and get a chance at figuring out what some of those words might be. That's the one problem I have with this, but otherwise his comic is spot on. So how do we make this better? Honestly, two-step verification or two-factor authentication, it's a great system because you get a notification when someone's trying to log in. Turning it on for important sites, I think, is a really, really good idea. Okay. The second authentication, you will get some kind of a token, either emailed or texted to you, and it will have a very short life cycle. I think texting is better. It's a lot harder to intercept that information than it is to intercept an email, but we have seen examples where people have successfully intercepted text by doing cloning of the SIM cards, SIM cloning. Any questions on that? Finally, test your passwords. Run your password through the common password lists. Run it through cracking tools once you've got a password hash. See how complicated it is. I don't use Cain Enable anymore. If you want, you can take a look at it. This course focuses almost exclusively on John the Ripper. We don't use Hashcat either. Although, do we use Hashcat? No, I don't think we do. Yeah, I don't think we use Hashcat in this course. So we're going to focus on John the Ripper. Okay. Some of the consequences led to many system failures, and because people are lazy, compromising it in one system allows it to be compromised in another. And there has been loss of life because of this. I don't know if you remember the Ashley Madison leak from a few years ago. Passwords, they were able to do a data dump, and it wasn't so much about the passwords, but because they were able to glean this information, people were embarrassed that they were actually on this site. It costs people their marriages, and some people committed suicide when their names were released to the wild. But not only that, which is bad enough, which is actually worse than the follow-up, but assuming another site that doesn't have that kind of stigma associated with it, another consequence is that they were hackers were able to go through the log files of this site, and they very quickly realized that high 90s% of the people on this site were men, and most of these men were either talking to bots or were talking to employees. They were able to trace back the IP addresses in the activity logs to realize that a lot of the women on this site were actually employees and may not have been women in the first place. So it's not only your customers that can be impacted, but it's your own company that can be impacted as well. Any questions on that? Finally, there's a site called Have I Been Pwned? You can verify the credentials that you're using. You can take a look. They actually have a database. I had the database up and running, but that server crashed badly, so I haven't brought it up on another site again. But they have a list of password hashes. They've done them in one way, but they've done them in really simple hashes, so it's very easy for you to type in a password, run it through the exact same hash, and see if that password is in that list. You may be saying, well, why would I bother doing that? Because if that password is in that list, then that's a compromised password, and you have to assume that somebody's going to create a dictionary based on that, because if you used it somewhere, you may use it somewhere else. Any questions on that? Does that make sense? Okay, just give me 1 second here, and I'm going to set up for VirtualBox. I just need to check something. Good. Oh, I should. Here. Sorry. Here we are again. So I've got an older version of VirtualBox, but it should be fine. And what we want to do, and again, we're still recording, so if you're worried, please don't be worried. I'll make this video available. But I've also made available a video in Learn as well. We are going to be using VirtualBox, and we're going to be using it in a manner very similar to what you saw in semester 1 with information systems. where we used VirtualBox to create a host-only network, and we have the machines talking to each other in that host-only network. We're going to set it up in such a way that you from the host environment can also talk to those virtual machines. Okay? You can create groupings for your virtual machines as well, and as you can see, I use this quite a bit. Nevertheless, I'm just going to create a new virtual machine. Click out there because I don't want it to be one of the subcategories. And this is the process. First off, you ensure that you've downloaded the latest version of Debian. I have it here in my downloads. I grabbed Debian 10.5 AMD 64 net install. Really doesn't matter at this point. They're all very similar. And what's most important is that we're doing, for Debian, we're doing a command line only, as I was mentioning earlier. This is command line only. We're not going to use the graphical tools. So when we get to that step during the installation, it is critically important that you select the right steps. But once you've got it downloaded, go into VirtualBox, create groups if you want. You can do that later. You can move these things around to different ones. But there should be a new. If you don't see tools, if it looks something like this, that's fine as well. Sometimes it looks like this. Sometimes it looks like this. That's fine. You do not need 4 different host-only networks. Don't worry about it. Okay? First thing we want to do, go to the preferences of VirtualBox. Not the settings of an individual virtual machine. What we want to do is we want to go to the preferences of VirtualBox, and all we really want to do is check our network settings. Now you used to be able to check your network settings right here. That's no longer an option. If you click on network and it doesn't say anything here, cancel out and go host network manager. That's really what we're interested in. And you want to ensure, please ignore 2, 3, and 4. That was for something else. Don't worry about that. We really want to ensure that we have a host network. If you do, you want to verify the settings. So you need a host network, you need to have an IP address, and you need to have DHCP enabled, and the addresses make sense. My adapter is 56.1. That's going to be the gateway address to my host-only network. I have a DHCP server, so they will dynamically assign IP addresses. This is important when it comes to doing pen testing. The lower address is 101, the upper address is 254. That's going to be the range of my dynamic addresses, which means that IP addresses 2 through 99 are available for static assignment. We're not going to get into that. We're going to do everything through DHCP, which will be fine. Okay? If you do not, click on the create button and you can create a new I'm just going to clean this up. Okay. If you do not have, you can click on the create button and it'll pop up a warning. I don't know if you can see that or not on your display, but it'll pop up a VirtualBox saying, hey, you're about to change your hardware. Are you sure you want Oracle to do this? You click on yes, and it'll create one. Do not do this indiscriminately because it can cause problems. If you do it this way, however, it does not automatically create a DHCP server. If you have to add a host-only network, you have to manually enable DHCP, and you should probably change the addresses. Not from 2 to 100, and then 101. Okay? If you have to do this, it's unlikely that the address is going to match my notes. My notes assume that you're using address 56. Okay? Once you have that, though, you have your host-only network. That's great. Because now you want to create a new virtual machine. Click on new, go file, machine, new, or right click. We used to be able to right click, I can't remember where it is. Anyway, create a new virtual machine. It defaults to Windows and for some reason Windows 7, but we're going to create a Debian box. If we start typing Debian, D-E-B, when we get to the B in Debian, it says, oh, you want a 64-bit version of Linux Debian, which is perfect. You are section 1, right? I believe you are section 1. Yes. So I'm going to create a virtual machine called Debian section 1. The defaults at this point are fine. Click on Next. 1 gig is probably enough. If you can give it 2 gig, that's even better. You don't need more than 2 gig. It's going to be lots, because again, this is a command line version of Debian, and really all it's going to be running is Jack the Ripper and a lamp stack. That's basically all we're going to do with this server. So 2 gig is lots if you can afford it. You want to create a hard disk. You want to create the hard disk now. You want to use the defaults. You want to use the dynamically allocated default, and the 8 gig size is more than enough. We're going to come in, as I said earlier, probably under 2 gig with our setup. And then we click on Create. Again, how did I do that? When I got to the point in the thing, I said create a virtual disk, click on Create, VDI, Next, Dynamic, Next, 8 gig is lots, click on Create, and then it'll kick you out of the wizard. You now have a virtual machine, you have a storage drive. It says it's an 8 gig partition, but it's not. It is at this point 1 sector on your hard drive. Until you start putting data in that file, it is going to just be 1 sector on your hard drive, which is like, depending on your formatting, like 8K or something like that. Okay? By and large, everything is going to be fine at this point. You can go into the system, you can bump up your memory, you can give yourself more cores if you want. 1 core should be lots, 2 gig should be lots. You can up your video display here, and we will when we set up Kali, but right now 16 gig is lots. Storage, we're going to take a look at this right now, or in a minute we'll come back to it. Audio, you can turn that off or leave it on, that's fine. Serial doesn't need. I would have USB enabled because you may use a mouse at some point. Even though we're command line, I'm going to show you how to use mouse shortcuts. So you want to keep USB enabled. Shared folders is out of scope. User interface, if you really want to dial in, you can add and remove stuff to the user interface. We'll talk about the user interface later on. So the 2 things we need to modify after we have set up our VM before we install is storage and network. Let's look at storage first. You've got 2 controllers here. You could have a hard drive on the SATA controller, but you've got the hard drive on the IDE controller, or maybe you have them both on the SATA. It doesn't matter. What is important is that you have a CD-ROM drive and there is no CD installed. Way off to the right of this dialog box is a little CD icon. We click on that and we can choose a disk file. We can also go through the wizard and use this, but we're not going to do that. The drop down should allow us to choose a disk file. It's the easiest. Go to your downloads, select the ISO that you downloaded, and click on open, so that the CD-ROM icon indicates that you've got your Debian install disk ready to go. Okay, this, it's 2 megas the cluster size. So it's an 8 gig partition, but I've only used 2 meg at this point, which is fine. Okay, so ensure you've got your CD-ROM selected, and then you can go to network. As I said earlier, we're going to do everything on our host-only network. And I should mention, there's also a document called Installing Debian in VirtualBox. You can also take a look at this document as well. And I'm just going to bring it up real quickly so I can show you something. I don't know if I have it in this document. I don't. Sorry. Okay, that doesn't help me. Maybe I have it in here. I don't think I have it here. Oh, good. Firefox is crapping on me. Okay, I can't find the diagram. I apologize, but we'll see it in a future class. It's okay. It looks like my computer is failing. Oh, isn't this fun? Isn't this new and different? Okay, hopefully it's not too badly damaged. Good, I still have control here. Awesome. Okay, so we're going to have two adapters in our environment. Adapter 1 is going to be NAT, and in this world, NAT gives you access to the internet, gives you access to the cloud, and that's really important. Adapter 2 is the adapter that we're going to attach to our host-only network. Okay? Ensure that you select the correct one. There should only be one. If you have more than one, as I do, make sure you select the correct one. So adapter 1 talks to the internet. Adapter 2 talks to the local network, and that's what we're going to use for our pen testing. Okay? When we set up Kali, it's going to be exactly the same. Adapter 1 is going to talk to the cloud. Adapter 2 is going to talk to the host-only network. When we set up the virtual machines to attack, there's only going to be one adapter, and it's going to be on the host-only network. But we'll talk about that in the future. All of our pen test activities happen on the virtual internal network, this host-only network. All the pen test stuff is happening there. Sometimes we need to talk to the cloud, so we have two adapters to differentiate that traffic, which is why we use DHCP, because we allow the DHCP server to do the gateway management. Okay? So, adapter 1 is fine. Adapter 2, enable, select the host-only network, and most importantly, expand advanced and set promiscuous mode to allow all. This allows the VMs to talk to each other and allows you from your host environment to talk to the VM as well, which will be important. Was there a question? Did somebody? Yeah. Okay. Yeah. I am recording this. Yeah, and you can talk to me later as well. That's fine. Yeah, no, you're going to have to reboot to do that. But do you have VMware running? Do you have VMware Workstation? No, I'm sorry, in other classes. Like, do you have VM Workstation running in other classes? Okay. Okay. So this is a different PC that you use normally. Then yes, we're going to have to go through the BIOS and enable it. Yes. Okay. So yes, I am recording this to answer your underlying question. And there is video as well that just has a bunch of pop-ups that you can step through as well. Okay? Any other questions? Thank you. Any other questions? Alrighty. Somebody chatted something. Okay. Good job, Dakota. Perfect. Good job. I love that you guys are helping each other. That's brilliant. If you have any questions for me, let me know. Okay, so now that we've got our hardware set up, we can click on OK. We've got our install CD. We've got our two network adapters set up. Everything else should be okay. We can start our virtual machine. And when we start our virtual machine, it says, hey, do you want to use this? And I say, yeah, I wanted to use it. That's why I chose it. I don't know if you're going to see that in newer versions, but sometimes you need to reinforce that. Now, in this one, we have the live menu. Now, you might think you can click, but you can't click because it doesn't work yet. We don't have a mouse yet. We want to do the install. Now, you can do a graphical install or a command line install. It's easier to do a graphical install. That's what I'm going to use today. But there is value for you going through and doing the command line install. It's the exact same steps, it's the exact same information, it's just a real interesting presentation. I encourage you to do that some point in the future. We can use the graphical install and still set up a command line only environment. We're just installing the graphics during the installation, or we're just using the graphics during the installation without actually installing them. Okay? Oh, shit. Thank you. I selected the wrong one. That one is the one that I want. Yes. Thank you. Thank you. No, I appreciate it because I would have gotten going and it's like, what the hell? It is Debian. So thank you for that, Kiki. And if you guys see me doing stuff like that, don't hesitate to point it out. Okay? That's much better. Yes. So you can do a graphical install or an install. We're going to do a graphical install even though we're going to use the command line environment. So select that and hit enter. And then it'll load a bunch of graphical libraries so it can give you this graphical environment. Please use English. I understand that not everybody speaks English, and I understand that this is going to be a little bit unfair, but frankly, a lot of developers don't develop language options properly. Like when they build an application, they hard code the language into the application without using language libraries properly, and it can cause problems. So I suggest you use English, not because I think English is better or anything like that, or I want to dismiss people's cultures. It just makes apps run better because app developers can be lazy sometimes. So I recommend selecting English and continue. We are in Canada. I would say select Canada by hitting the C on the keyboard, like we were down here in the United States. If I hit C on the keyboard, it takes me right to Canada, and continue. Depending on your keyboard, you want to use that layout. If you have a Canadian keyboard, American English should be fine. We can change that later. I usually recommend selecting American English. It will take a look at what's on the CD and it'll install the basic components necessary. Before it gets going though, it's going to want to do some network settings. Oh, and we need to set up our hard drive as well. So it's just pulling some components together so it can start the next step. It's going to find 2 network adapters, and we did this on purpose. We know our first adapter is NAT. It's asking us which one do you want to use as the primary interface during the install. It has to go out and download content from the online software repositories. So whichever adapter, if you're following along, it should be adapter 1. Whichever adapter you sent to NAT, that is the adapter you want to tell the installer to use as the primary network interface. Okay? So select adapter ENP0S3 or the first adapter and click on continue. It'll auto configure it with IPv4. It should give it the IP address 101 if your network hasn't been used in a while. I never know what mine is because I use this all the time. Okay? And now we need to set up a machine name. The default is fine. You can call it whatever you want. You can call it Charlie Brown's Kite Eating Tree. It's a variable name my high school teacher used to use all the time. She was my favorite teacher. I bring it up in classes just to pay homage to her. She was a great teacher. Anyway, you can use Debian. That's fine. But I like short. I like short usernames. I like short machine names. It gives me a shorter prompt in Debian, and it makes it easier for me to type in longer commands when I'm in the terminal. So I always use short host names such as Deb. You can type in whatever you want and hit enter. The domain name, the domain we use is opsys.bit. You can leave that blank. This is paying homage to an instructor that used to teach at Red River who's no longer with us, unfortunately. So the domain name I use is opsys.bit. You can use whatever domain you wish. And now it wants a root password. Yeah, Nick Sades, we lost him a couple of years ago. Now we can use a root password. This password, as we just said, should be complicated. Now don't type it in and click on next or continue just yet. This should be complicated. It should be unique. It is the, pardon the language, the hand of God access into your system. So in a production environment, you want this to be as secure as possible. However, this is an academic exercise in a closed environment. Make your life easy. Use the same simple password for everything. For example, I am going to use the password generic. You use whatever password you want. Don't make it hard on yourself. And keep using that password over and over again. And click on continue. You want to add a new system. They say the full name. I just type in my username. Again, I keep it short. It'll use that as the same username, and you need to specify a password. You can use the same password as before, generic, whatever you want, it's okay. We're going to be cracking these passwords in the future. You will see that regardless of the degree of encryption that you use for passwords, if you make your password easy to guess, easy to crack, let me say that again. Regardless of the encryption algorithm that you use, regardless of the degree of complexity of that algorithm, if you use a crappy password that's in a dictionary, it will be compromised regardless of the degree of complexity. And that's what we're going to see with these really bad passwords we have here. Okay? You do need to create a username that is not root. You can't do the root password. You have to use, you can do the root password, but you can't log in remotely as root. We'll talk about this in the future. So, that's fine. Create a new user and create a separate password as well. Or use the same password again. Okay? And click on continue. We are going to be doing remote access to this machine. We are going to need to ensure that we have the correct, or that we have a user that we can log in remotely with. Okay? Central time, continue. It's going to find the disk that we defined earlier, and we need to set up some partitions on it. We should use the entire disk. You know what? The defaults at this point are fine. Default, continue. Default, continue. All in one partition, that's fine for what we want to do. This is not a production environment. Continue. And then it says, I want to make these changes. Continue. It's on this screen that you have to say yes. Up until this point, it hasn't changed the hard drive. Now, Debian is aware that this is a virtual environment, but as far as the installer is concerned, it is saying, hey, I'm going to change the hard drive here. Are you sure you want to do this? The answer is yes, because the hard drive we are changing is actually the file that we created that is the virtual hard drive for our virtual machine. Okay, so default, default, default until you get to this screen. Click on yes and continue. It'll then copy the base system to that newly created file system that you just created. And then we can walk through. Are there any questions? Welcome to the wonderful world of IT. We get to watch progress meters for most of the entirety of our careers, but let's take advantage of this. Across the bottom, you've actually got a bit of a status bar indicating activities. If you move your mouse, you will see the green light on the USB icon. You can see file I/O happening on the hard drive, and as it reads from the CD-ROM, you will see green for read and you'll see red for writes. When we start doing the network, you will actually start seeing traffic happening across the network icon as well. This is very handy to see what's going on inside of your environment. the status bar inside the virtual machine's interface. At this point, it says, do you have another disk? No, I do not have another disk, and continue. And I'm just going to keep going and using the defaults. So Canada, continue. It's going to say, what do you want to use? ftp.ca.debian.org is probably the best. We've used other ones at other schools, and they've disappeared. I think we've inadvertently hammered these repositories. So use the ftp.ca.debian.org or simply deb.debian.org. Do not use any of the schools or the iWeb ones because I think we actually overuse them. We have like 20 students hitting it all at once, and then next thing you know, 2 weeks later it disappears. So ftp.ca.debian.org is never given me grief. That's the one we want to use. You should not have proxy issues at your home. If you do, you know what to add here to address that. Most of us on our home networks do not need to add proxy information. And then if you can see it doing retrieving files and you can see network activity happening in your status bar, that's a good indicator that you're on the right path, and you can start the installation process. This screen is very important. Okay? The next screen. I believe it's this screen. Oh, sorry, no, this one isn't as important. Sorry, it's coming up. One of the things it wants to know is we want to volunteer for the popularity contest. And what this is basically it tracks the software you use and sends the information back anonymously to Debian. I think this is a great idea. I have no problem sharing my use statistics back to Debian. My pushback is I don't think we should be doing this in an academic activity. I don't think the pen testing stuff we do with Debian should drive future content as part of the base libraries for Debian, for future Debian releases. I always leave this to no. Not that I have a problem with it. I don't want to skew the results with what we do in this class. So say no and click on continue. And it's this next screen that I want to be clear on. Clear all the check marks. All the check marks need to be clear except the bottom two. SSH server, because that's how we're going to log in, and standard system utilities. Everything else is clear. No desktop, none of the desktop managers. We will add our own web server, we'll do it manually, and we are not using it as a print server. So none of the other checks except SSH and standard system utilities. There should be only two check marks, and they should be at the bottom of the list. And then you can click on continue and it'll start the install process. I've got a pretty good pipe coming into my apartment, not to brag, but I am going to brag. I apparently have fiber right up to my apartment, which is pretty cool. It's a new building and a recently developed neighborhood in the downtown area, and fortunately I've got fiber optics literally to my apartment, which is pretty cool. Makes things a lot faster. Okay, so Brendan, so just hit the back button and select a different server. Okay, if you only have standard system utilities, you may have downloaded the wrong image, but chances are you specified the wrong repository. So click the back one and select the ftp.ca.debian.org repository server. Okay? Okay, so follow along and we'll take that offline because I'm almost done. Okay? So if you're having problems, just pause there and we'll take a look at it. You might need to restart Braden. Sorry, not Brandon, Braden. I apologize, Braden. Okay? So, I'm just going to play this through. Oh, I should wait for you guys. There's two things that impact the overall speed of this installation. One of them is your internet pipe. If you've got a crappy pipe, or you've got a not too crappy pipe, but you're sharing it with a bunch of roommates and everybody's on at the same time, it's going to go slow. That's one thing. The other thing that's going to dictate the speed of the install is the hard drive you're using. I've got a very good pipe and I've got a solid state drive that I'm installing Debian to. Both of those make the installation quite quick. Veering away from those is going to add a little bit to the install time, but at this point it's very simple. Okay? I don't know if you remember this from semester 1, but you need 3 things to boot into an operating system in the PC world. Does anybody know what they are? I know, right? How dare I make... Yes, exactly. Who was that? Carlo? Was that you? That was Juan? Awesome. Brilliant. That's exactly what I was looking for. You need a BIOS, which you have virtualized. You need an operating system, which we just installed. And the third piece you need for PCs is a bootloader. You see that with Windows when you hit the F8 on boot. And that's what we're installing now. Grub is the bootloader that Debian will use to boot. And again, the defaults are fine until it says, hey, do you actually want to modify a hard drive? At which time you have to say exactly what you want it to write to. So do you want to install Grub? Yes, because I need a bootloader to boot into this operating system. Then it says, where do you want to enter it? Because it's going to overwrite the boot sector of the hard drive, or the UEFI of the hard drive, you have to explicitly say, install it to this device. Do not enter it manually. Select the device, the SDA, which is the first SATA hard drive. It thinks it's a SCSI, it's not, it's a SATA hard drive, but that's fine. Click on continue. It will install the Grub bootloader for you. It will finish the install. It'll delete any temporary files. At this point in the Kali install can actually take a few seconds, and then it says it's complete. Take out the CD-ROM for the CD-ROM tray, which we don't have to worry about. We can click on continue, and it will reboot the system into Debian. Now we're booting off of the virtual machine's hard drive, not the CD-ROM. And just like before, you can log in as root. Who am I? You are root. Or you can log in as the user you created. Who am I? SJ. Okay. Other than the 1 or 2 people who had problems, we're coming back to you. Anybody have any questions at this point? Okay. I'm going to stop there. That's it for today. You can take a look at some of the other setups that we're going to take a look at, but we're really going to focus on those next week. If you want to start taking a look at the password stuff, that's fine as well. Sorry, excuse me. But I'm going to stop there and let everybody get caught up and up to date. Also, I can't go too fast this week because, again, Section 2 has missed the first 2 hours because of Labor Day yesterday. So, again, it's another one of those weeks where your guys are going to get a couple of more extra time of lab time in class because I want you guys to progress as a single unit as much as possible. Alrighty? If you've... No, not for this week. No, sorry, that's it for today. Next class, we're going to actually install John the Ripper. We're going to use a tool called Change Password, CHPASSWD, to create a bunch of user accounts so we can actually take a look at a password audit. And we're going to see what happens with, it doesn't matter the degree of encryption that you use. We're going to see what happens when you use a bad password is a bad password, regardless of how well it's hashed. And that's what we're going to see in our next class. That's it for today. Okay, great question, Scott. Thank you. Any other questions?